You are standing in your garden in July, and you see them. Aphids, mealybugs, spider mites clustering on the underside of every new leaf. You count 40 on one stem alone, maybe 50. 3 weeks ago, there were none. Now your tomatoes are sticky with honeydew. The leaves are starting to curl. The growth has stopped. You have a harvest that depends on stopping this in the next 48 hours. Here is what I want you to understand before we go further. That infestation did not creep up on you by accident. It is happening because those insects found what they need: soft bodies, thin skin, zero defense. Now, I have spent 2 decades working with a solution that exploits exactly that weakness. My mother began this work 30 years before I did, on her orchard in Shizuoka. She never bought a bottle of synthetic pesticide in her life. What I am going to show you in the next 4 chapters is her method refined. Today, how salt, plain salt dissolved in water, collapses a soft-bodied insect in seconds through osmosis. By the time we finish, you will know 4 techniques that move from simple to lethal. But here is the part that most people miss, and I will come back to it at the end. Stay with me, because the reason this knowledge nearly vanished matters more than you think. First, you need to understand what happens inside an aphid when salt touches its skin. The salt solution is hyperconcentrated, roughly 35 grams per 100 milliliters of water. That is 10 times saltier than seawater. When it contacts the aphid's thin cuticle, osmosis begins instantly. Water inside the insect cells is pulled outward across the cell membrane. The cell collapses, then the next cell, then the next. Within seconds, the insect has desiccated from the inside. Nerve function stops, the body goes rigid, death. The insects most vulnerable are the soft-bodied ones: aphids, mealybugs, spider mites, thrips, whiteflies. Caterpillars too, especially the small ones. But here is where it gets interesting, and where my method changes everything. The solution must touch the pest directly. There is no systemic action, no residual protection. You spray, it kills what you hit, and then it stops working. Which means timing matters more than poison. When you spot them, the moment you see that first cluster, that is when salt is most powerful. This is also why the next chapter exists. Salt alone is fast, but salt is only the beginning. What you layer on top of it determines whether those insects stay dead. Oil changes everything about how this works. So the salt worked. Your aphids dropped inside seconds, but you glance up and see the mealybugs are still moving on the undersides of leaves. Oil does what salt cannot. It coats the entire body and seals every opening the insect uses to breathe. You are standing at your sink, holding a bottle of food-grade oil. Neem, canola, horticultural mineral, it does not matter which one yet. Inside every insect's thorax and abdomen run tiny tubes called tracheae, like plumbing that carries oxygen straight to the tissues. But the tracheae only work if oxygen can enter through small openings called spiracles, little doors running down both sides of the body. Block those doors with oil, and the insect suffocates in minutes. The epicuticle, that waxy outer layer I mentioned before, meets the oil and dissolves, like butter into hot water. Once the wax breaks, the insect loses water through its skin faster than it can hold it. You now have 2 killers working together: suffocation from blocked spiracles, desiccation from a shattered waxy coat. I dilute my oil with water using a surfactant, usually already in the bottle, to make it cling as a fine mist to leaves and stems. The oil droplets must reach every surface, undersides especially, because the crawler stages hide there and spiracles need complete coverage. Here is what I do with a heavy infestation. I spray until the leaf is visibly wet, not just dampened. Undercover means survivors, and survivors mean I come back in 5 days spraying again. Mealybugs hide under their waxy filament coat. The oil penetrates it and suffocates the body beneath within 3 to 4 minutes. Spider mites have book lungs instead of spiracles, but oil blocks those openings just as effectively. Caterpillars run a row of spiracles down each side. I coat the entire lateral surface so no breathing hole stays clear. The physical kill means no resistance. The bug cannot evolve immunity to being coated and drowned. And I have to be honest with you about this one. Oil burns leaf tissue if the sun is too hot or the plant is drought-stressed. Water your plant before you spray, and apply only in cool morning hours or late evening. The oil itself breaks down in sunlight within days, leaving no poison in your soil. But salt alone cannot reach every hiding place and crevice a heavy infestation occupies. What you need next is a tool that dissolves the very wax protecting the mealybugs under skin, something that works with oil to leave nothing standing. Oil alone cannot reach every hiding place, so now we layer something that dissolves the wax before oil even arrives. I am talking about soap, but not the dish soap in your sink. The soap I use is potassium salts of fatty acids derived from coconut or palm oil. It works as a surfactant, meaning it breaks down the waxy epicuticle the same way it breaks down grease. You are looking at an aphid colony under morning light, clustered on a stem. That white, protective coating you see covering the mealybug, soap dissolves it from the outside in. Once the waxy layer cracks, the insect cannot hold moisture anymore. Desiccation happens fast, within minutes, because the cuticle no longer seals the body. Here is the critical part. The spray must stay wet on contact to kill. Once it dries, there is no residual poison, no hidden death waiting for the next crawler. That is actually the gift. Beneficials like ladybugs are safe once the spray has dried. The ratio matters tremendously. 1 to 3% solution is the sweet spot. That is roughly 1 to 3 teaspoons of Castile soap per quart of water. Go above 3% and you burn the leaf tissue, not just the pest. I learned that mistake on young seedlings in 2008 and lost an entire bed. Soft water works better than hard water. Minerals in tap water bind with soap, weakening it. I use distilled water now, and the difference is visible within one spray cycle. Apply early morning or late evening, never in direct sun, so the soap stays wet longer. You need complete coverage. The undersides of leaves, the stem joints, everywhere the colony hides. Mealybugs are the stubborn ones. Their cottony wax is so dense you may need to soak them twice. But here is the honest part. Soap does not kill eggs. Eggs sit in their own protective coating, waiting for nymphs to hatch. That is why persistent populations need repeat sprays every 4 to 7 days. You are breaking the reproductive cycle 1 generation at a time. And here is where it gets interesting. Soap does something else most people miss. It breaks down the sticky honeydew the aphids leave behind, starving the sooty mold that follows. One spray solves 2 problems at once. Now, most people think this is where the killing ends. But on the hardest infestations, on the colonies that seem to laugh at salt and oil alone, there is one more move. I learned it from my mother, who learned it from her grandmother in Shizuoka. It layers all 3 in a sequence that leaves nothing alive. With salt resting on leaf and oil coating spiracle, the next move decides everything. Now, here is where it gets interesting, the part I promised you at the start. You are standing over a mealybug colony, the worst infestation you have seen in months. The white waxy coat protects them. Salt alone bounces off. Oil alone cannot penetrate. So here is what I do, and my mother taught me this 30 years ago. I mix all 3, not one after another, all at once in sequence. First, I spray the salt solution directly onto the colony until every insect glistens. I wait 90 seconds, The osmosis begins. The cuticle starts to crack from inside. Then, while the salt is still wet, I spray the soap solution over the same area. The soap dissolves the waxy layer that the salt is already stressing from beneath. 30 more seconds. The protective coat fails. The insect membrane is now naked. Now the oil goes on. Complete coverage, runoff to the leaf edge and stem base. The oil finds spiracles already exposed. It finds cuticles already weakened by salt and soap. 3 kill mechanisms arrive at the same moment. The colony cannot mount a single defense. Most insects die within 4 to 6 minutes. Even the hardened ones fall by 8. I have done this on mealybugs, thrips, scale crawlers, and small caterpillar clusters. 1 treatment, 1 cycle. The colony does not recover. And I have to be honest, this only works if you cover everything completely. A single insect missed in a leaf fold survives and rebuilds the population. So you must slow down, you must turn the leaf, you must check the stem base. That is the nuclear option. That is the technique that ends it. Look at what we have just walked through across these 4 chapters. Salt triggers osmosis and desiccation in seconds when the insect is exposed. Oil blocks the breathing pores and suffocates what survives the salt. Soap dissolves the wax coat that normally shields soft-bodied pests from everything. Together, they eliminate nearly every colony in 1 treatment if you apply them right. You are now standing in your own garden, looking at whatever pest you spotted first. You see the aphid, you see the mealybug, you see the thrips on the undersides. You know exactly which tool reaches it, and you know why it works. That changes what you do next. Now I want to hear from you. Which of these techniques have you tried, and what did you see happen? I read every comment you leave, and I want to know what works in your garden. The pest does not decide the outcome. You do.